Hello everyone, welcome to CodeTav Management. So, in our previous episodes, we learned about the system design, the fundamental concepts of system design. After that, the functional and non-functional requirements. After that, the difference between uh, high-level design and low-level design. So now it's time to learn one of the most important skills that every software architect and backend engineer must master. That's nothing but the capacity estimation and back of the envelope calculations. So this capacity estimation is also known as the back of the envelope calculations actually. But I have given these two names as well here to understand better. So one of the biggest mistakes actually candidates make during system design interview, that is basically immediately drawing servers, databases without understanding how much traffic the system is expected to handle, right? So before selecting a database, deciding on caching or planning horizontal scaling, we first need to estimate the system's capacity. So in this video, we will learn how to estimate users traffic, request per second like RPS, then the storage, bandwidth, capacity, cache, database size. So those we will actually understand step by step using some simple mathematical calculations as well. Okay. So I hope in the YouTube that type of video is not present. But if present, I am very happy. But yeah, I'm just going to prepare in that way. Like how before implementation of any project, how architects basically think. So in that way also you need to explain during your interview as well, system design interview as well. So what are we will discuss. So here is what we will cover in today's session. You can see. So we will start by understanding what capacity estimation is, why it is essential before designing any system. And then we will learn how to estimate daily active users, the DAU, the monthly active users, MAU, concurrent users, request per second. After that, we will calculate storage requirements, bandwidth consumptions, cache size, database size, and finally, we will solve some real world example using Instagram, WhatsApp, Netflix, Amazon, and discuss how interviewers expect you to approach capacity estimation questions, right? So, what is capacity estimation actually? So, capacity estimation is basically also called as the back of the envelope calculation, right? So that is the process of estimating the infrastructure required to build a scalable software system. So instead of immediately thinking about servers or database, architects first ask questions like how many users will use the application, how many requests will the system receive every second, how much storage will be needed, how much bandwidth will be consumed, how large should the cache be, means the cache size. So uh, how the servers perform. So these estimates basically help us choose the right architecture and avoid both under provisioning and over provisioning, right? So always remember these are the rough estimates, not the exact values, but they are sufficient for making architectural decisions. Okay. So why capacity estimation matters? So what I have told, like why it is important. So in the same way, like imagine launching an e-commerce application without estimating the expected traffic. So initially everything works well because only a few hundred users access the system. Now suppose a festival sale begins and suddenly thousands or lakhs of users try to log in, search the products and place the orders at the same time. So if the architecture was not designed for this much traffic, so servers become overloaded and response times increases. Okay, so users start leaving the platform, like performance will be low, and that's why the users will not love your product or your platform. So that's why capacity estimation helps us avoid these problems. So that's why, like, in this way, it ensures that the application can scale smoothly, deliver consistent performance, and optimize infrastructure costs, and provide a better user experience. So without estimation, application crashes during peak traffic, database becomes bottleneck, high response time, poor user experience, increased infrastructure cost. And with proper estimation, better scalability, better performance, better cost optimization, and better infrastructure planning, right? So now we will see the capacity estimation workflow. So professional architects follow a structured approach. The first, they first actually understand the business requirements. Next, they estimate the uh, number of users. After that, they calculate the traffic, then request per second, storage, bandwidth. They also estimate the cache size and database size. Okay. And only after completing these calculations, okay, they basically start to begin like designing the system architecture. Okay. So before designing the architecture, these things are very much necessary, right? So now basic assumptions. So every system in design interview begins with assumptions. So suppose we are designing a social media application. Okay. So we may assume there are suppose 10 million registered users, right? And 3 million monthly active users, MAU. Okay. So, and like 3 lakh daily active users, DAU. So each user performs suppose 20 actions per day. So peak traffic is 3 times the average traffic. So suppose peak traffic we are calculating as 10% of the DAU. Okay. And average request per user is 20 per day. So average image size is suppose 2 MB, average API response is 100 KB. So always tell the interviewer your assumptions before calculating. Now daily active users versus monthly active users. So let's understand two important metrics. The monthly active users or MAU represent the number of unique users who use the application in 1 month. And daily active users or DAU represent the number of unique users who use the application in a single day. So for example, if a streaming platform has suppose uh, 3 million monthly active users and about uh, what I have told here, like 3 lakhs users access it every day, like the DAU, then the DAU is like roughly 10% of the MAU, right? So if you will calculate 10% of this 3 million, you will get the 3 lakhs. So these metrics help us estimate traffic and infrastructure requirements. So here also I've given one example for Netflix. Suppose MAU is 50 million and daily active users is 5 million. So relationship DAU is almost like 10 to 30% of MAU. Okay, what I've told. Like suppose MAU is 3 million, then DAU is at about 3 lakhs. So now why DAU matters? So DAU actually determines the regular average traffic, API calls, server load, database connections, cache size. So if we can able to calculate daily basis, or if it will be like high impacted application, so then you also need to calculate hourly basis, 15 minutes basis, 45 minutes basis, per second basis. In that way also you need to calculate. But initially you have to calculate monthly basis, daily basis, like that. Okay. So now concurrent users. So Not all users are online simultaneously, right? So suppose our application has 5 lakh daily active users. So if approximately 10% of them use the application during the busiest hour, so we get around suppose 50,000 concurrent users. So this number is extremely important because the architecture must be designed to support concurrent users, not just total daily users. So load balancers, application servers, databases, and caches are all sized based on the concurrent traffic. So your system should be designed to support this 50,000 concurrent users, not just 5 lakh daily users. Now requests per second. So we will calculate the request per second. Suppose there are and the formula request per second means total day is 24 hours. If you calculate to seconds, 24 multiplied by 3600, you will get this value 86,400. So suppose example like 3 lakh multiplied by, suppose users is actually 3 lakhs and each user makes 20 requests per day. So total request 3 lakhs multiplied by 20. So 6 million requests per day. So RPS will be 6, like whatever 6 million. So this 6 million divided by 86,400, roughly 69 requests per second. And peak traffic usually 3 times multiplied by average peak RPS, and which is like 69 is the like average peak RPS. So for peak traffic multiplied by 3, so in that time it will be 207 RPS. So always estimate the peak RPS, not the average. So if your system will able to handle this peak RPS, then you are fine. Your system is fine totally. Okay, so always calculate peak RPS because that's when the system experiences the highest load. Now read versus write ratio. So different application have different read and write patterns. So for Amazon, users search products far more often than they place orders. So mainly they search the products. So this makes Amazon a read heavy system. So that's why you can assume the ratio of read and write of Amazon is 100 is to 1. For Instagram, 50 is to 1. WhatsApp, 3 is to 1. Banking, 1 is to 1. So for banking application, however, involve frequent account updates, transactions, making write operations more critical. So that's why you can assume 1 is to 1. So understanding the read to write ratio helps the architects decide whether to use caching, read replicas, or specialized databases. Okay, so read heavy systems benefit greatly from caching and read replicas, and write heavy systems require strong consistency and optimized write paths. Now, storage estimation. So suppose users upload 1 lakh images every day. Each image size is 2 MB. So daily storage becomes 1 lakh multiplied by 2 MB, which is approximately 200 GB per day. So monthly storage become approximately 200 multiplied by 30, which is 6 TB. Okay. So yearly storage 200 multiplied by 365, which is approximately 73 TB. So these calculations help determine the storage infrastructure and backup strategy. So add the backup and replication like primary database 73 TB, replica 73 TB, backup 73 TB, and total, which is 73 multiplied by 3, which is 219 TB. Now database size estimation. So let's estimate the database size. So suppose each user record occupies about 400 bytes. How it is? So suppose user table fields like suppose user ID 8 bytes, name 50 bytes, email 100 bytes, phone 20 bytes, address 200 bytes. So if you calculate the total, so it approximately 400 bytes per user. So suppose users, 10 million users are using your application. So multiplied by 400 with 10 million, which is approximately 4 GB. So always add indexes. So indexes usually increasing the storage by 20 to 40%. So this is why database estimation always includes additional uh, overhead. Now cache estimation. So caching actually improves the application performance by storing frequently accessed data in memory. So instead of querying the database repeatedly, the application retrieves the data from the cache. So like example of cacheable data include like some trending videos, user sessions, popular posts, hot data. Okay. So suppose the frequently accessed dataset size is 20 GB. Okay. So a Redis cache of around like 20 to 30 GB, that would be sufficient. So cache hit ratio, like target cache hit ratio, is approximately 90% significantly. That basically reduces the database load and improves the response time. Okay. After that, bandwidth estimation. So bandwidth basically measures how much data the system transfers over the uh, network. So bandwidth is request per second multiplied by payload size. So suppose your request per second is 500, payload size is 100 KB total. Like if you calculate the bandwidth, that is approximately 50 MB per second. Hourly, you have to multiply it by 3600, which is approximately 180 GB per hour, and daily basis for you have to multiply with 24, which is approximately 4.3 TB per day. So bandwidth estimation is especially important for streaming services and media heavy applications like Hotstar, Netflix, like that. Now CDN estimation. So static content such as like images, videos, CSS, JavaScript, and fonts should not always be served directly from the application servers. So instead, there is content delivery networks, CDNs. So that basically store these files closer to users around the world. So this reduces the latency, decreases the bandwidth consumption on like origin servers, and improves the user's experience. So large platforms like Netflix, Amazon, YouTube rely heavily on CDNs. So now one by one I will give you some examples. So suppose Instagram case study. So let's estimate capacity for Instagram. Suppose there is 10 million users. Okay. Now the DAU, like daily active users, is suppose 1 million. Now uploads per day is suppose 2 lakhs. Each photo size is 3 MB. So now calculate the storage per day. So storage per day is like 2 lakh multiplied by 3 MB, which is like 600 GB per day. So yearly, you have to calculate like you have to multiply it with 365 approximately. You will get 219 TB yearly. So yearly storage exceeds the 200 TB. So this clearly indicates the need for scalable object storage, Redis caching, and CDN integration, and replicated databases, metadata databases. Okay, this much heavy size when it is. Now, WhatsApp case study. So suppose WhatsApp has 50 million active users, and each user sends 40 messages per day. Just assume. So total 50 million multiplied by 40, which is 2 billion messages per day. So now think about the challenges, like where do we store these messages? How much bandwidth is required? How do we ensure message delivery? So this demonstrates why capacity estimation directly influences architecture. So you need to estimate database, message queue, bandwidth, storage, notification service, right? Next is like Netflix case. So Netflix presents a completely different challenge. So instead of small text message, or Netflix basically streams high quality videos. So suppose 2 million users watch videos simultaneously. So if each stream requires uh, 5 Mbps, the bandwidth requirement becomes enormous, very high. So this is why Netflix relies on distributed CDNs, intelligent caching, and geographically distributed servers. Okay, so that is very much unique thing for Netflix is distributed, like not like only the distributed servers, like it is geographically distributed servers to maintain its high quality. Now Amazon case study. So like now consider Amazon, like millions of users search for products every day. So search operations are far more frequent than purchase. So the architecture must support high read throughput, fast search responses, large product catalogs, secure payment processing, reliable order placement. So 5 million daily active users. So orders suppose 5 lakhs per day, searches 50 millions per day, payments 5 lakhs per day. So you need to estimate the RPAs, database, cache, bandwidth, storage. So in this way, capacity estimation basically helps determine like how many servers, databases, caches, and load balancers are required. So during interviews, always follow this structured approach. Like first understand the requirements, estimate the number of users, calculate daily active users, estimate concurrent users, calculate request per second, estimate storage, estimate bandwidth, estimate cache, estimate database, and after that, finally, you need to draw the architecture. So after estimating all these things, your architecture, like drawing the architecture step, will come up. Okay. So common assumptions, like here are some assumptions commonly used in interviews. Like suppose peak traffic is approximately three times the average. Daily active users usually between 10 to 30% of the monthly active users. Cache hit ratio is around 90%. Indexes consume like 20 to 40% additional storage. So always explain that these are assumptions and can be adjusted based on the business requirements. So read heavy systems benefit from read replicas and caching. Write heavy systems need optimized writes and consistency. So candidates often make these mistakes. Suppose they skip the capacity estimation and immediately draw architecture, what I was telling earlier as well. So they ignore the peak traffic, they forget replication and backups, they underestimate storage growth. They don't explain their assumptions. Avoiding these mistakes makes your interview approach much more professional. So some keep these tips in mind. So always round numbers for easy calculations. So think about future growth. You explain your assumptions. Focus on the peak traffic. Estimate the storage, bandwidth, cache, database before discussing the architecture. So interviewers are not just checking mathematical accuracy; they are evaluating your thought process. So it's not very much required that you are calculating correctly or not, but the thing is you are thinking in that way. You thought about the user's experience. That matters actually. Before building or before architecting the applications, you were thinking about like how users will experience. So that matters. So let's quickly revise the important formulas what I have discussed. So daily request is like daily active users multiplied with request per user. Request per second is like Daily request divided by 86,400. Peak RPS is average RPS multiplied by 3. Daily storage is uploads multiplied by file size. Yearly storage is daily storage multiplied by 365. Bandwidth is like request per second multiplied by payload size. Concurrent users is daily active users multiplied by peak percentage. So these formulas are frequently used in system design interviews. Okay. So uh, so let's summarize today's lesson. So capacity estimation is the foundation of every scalable system. So before designing architecture, always estimate users, traffic, request per second, storage, bandwidth, cache, database size, and remember that these are approximate calculations and used to guide the architectural decisions, not exact production values. Okay, so a well estimated system is easier to scale, more cost effective, and more reliable. So maybe in the next episode we will dive into the load balancers, where you will learn how traffic is distributed across servers, the difference between layer 4 and layer 7 load balancers, popular load balancing algorithms. Um okay, so sticky session, what is the sticky sessions, like health checks, and real world implementations using Nginx, some HA proxy, and cloud load balancers. So if you found this video helpful, don't forget to like the video, subscribe to CodeTav management, and share it with your others other friends, okay, who are preparing for system design interviews. So thank you for watching, and I will see you in the next video. Okay, bye.